Okay, in order to implement squash and stretch on this animation and maintain the ability to rotate the ball, we're going to have to get a little more technical. And I want to show you why we have to do that. So let's go ahead and let's take our ball out to its first contact point here. Okay, so here we are, we've contacted, and the ball is rotated. You know, we are going to animate some rotation on this ball, so we want the freedom to be able to freely rotate the ball. Now, squashing and stretching is basically scaling the object. And as you can see, that changes where our contact point is. So we gotta lower it and you gotta rotate it. And so you're gonna quickly wind up in a situation where you're gonna have to animate a lot of nitty-gritty stuff and you're gonna have your ball rotating, and due to the way that the rotations are being calculated through Euler angles, is you're not necessarily going to get rotations that make a lot of sense going from bounce to bounce. Now, we could use quaternions to handle that rotation, but that's a little more complicated, as the quaternions calculate the rotation in a spherical space and calculate rotations as the shortest distance between those spherical spaces. It's a little harder to wrap your head around when you're first starting out, so we're going to stick with Euler angles. But in order to get a good squash and stretch, which we need, it's one of the most important principles. I shouldn't say most important, because honestly all of the animation principles are important, but squash and stretch is one of those principles that once you add some squash and stretch to your animation, it has a whole new life. It's got a whole new level of character to it. So we need to make some sacrifices. We're going to need to move some of the data around that we've generated. So since we got to get into the node editor and start moving some data around, let's go ahead and go through our little outliner here and rename things. So pSphere 1 is going to become ball, pCube is going to become box, pPlane 1 is going to become the ground or floor, pPlane 2 is going to become Z-wall, because that's the wall along the Z-axis, and pPlane 3 is going to become X-wall, as it's the plane along the X-axis. Alright, so we've got things named for some clarity, and now we need to start moving we got to move all the animation that we did on our ball with translate X and translate Y. We've got to move that to another node and drive the ball with that new node. So in the outliner with nothing selected, press Ctrl G. That will create an empty node located at the center of the world, 0, 0, 0. So let's take this null, let's rename it ball underscore transform underscore squash and stretch. Okay, so in order for the animation to transfer cleanly, we need to get this to center right along with the ball. So if you select the ball, you can see that it's got a translate values of -7.51 and 0.431 and 0. So let's just copy these values, enter them manually from here, -7.51 and 4.31, onto our ball transform squash and stretch. -7.51 and 4.31. There we go. It's centered right there. And let's go ahead and set a keyframe right here at frame 1 for our ball transform squash and stretch. So now if I select the ball, you see that the new transform is in the same place as the ball's transform. So let's copy the animation channels over one at a time. Maya gets a little upset if you don't do it one at a time. So selecting translate X, press Control A. Oops, no, sorry, that just doesn't work. I forgot that that's the attribute editor. Just drag a box around all the keyframes. Make sure you're getting that all the way out to 200. We'll stretch the timeline out all the way to 200 to make sure that we do. Go up here to Edit, Copy, select the new transform, select Translate X, and go to Edit, Paste. And if we press F, we should have a nice translate going all the way up. And if we... Okay, why is it doing that? Did it copy? Oh, look at that, it copied to every channel. That's not what we want. So let's select translate X, edit, paste. Okay, should follow just fine now. Yep, it's copying it on translate X. It's not following translate Y yet, but the translate X is there. So go back to the ball, select translate Y, zoom out a bit, make sure you get all the keys. You got them. All right, selected. Go to edit, copy, go to ball transform, select the Y channel, make sure you select it, press edit, paste. There we go. So now as we scrub through, we should see the new transform following the ball. So let's do a play blast real quick to test that. Hopefully it will show my transform still, my handle. Nope, it doesn't. But I can see here just by playing and stopping it that it's following it faithfully. So we're going to go ahead, we're going to select the ball again, select translate X, translate Y, translate Z, zoom out, draw a box around them, and delete them. Then take your ball and middle mouse drag it onto the new transform, the ball transformed squash and stretch, and drop it. Now, when you play, there you go. You've copied the animation from one node to another. So now, we're going to be able to do some squash and stretch. So if I grab this, pull it down, stretch it out in the other directions, and then I go to the ball again, and I press E for rotate, I can rotate it, and the squash and stretch remain. That's pretty cool. And I've got the freedom here too as well to rotate this. So I can have two different layers of rotation. And the ball is now rotating inside the deformed, elongated transform of the squash and stretch one ball. Okay. So that brings us to our next problem with squash and stretch. So squash and stretch operates on scale. And let's change before we get into that on how squash and stretch operates. Let's clean up some of the rotation here. So we've got values on the rotation. Let's go ahead and delete those keyframes, selecting the ball and then deleting the rotation, and then go up here to the rotate channels, select them all, and zero them out. Okay, so the rotate is zeroed out. Now let's go to the squash and stretch node. Let's see, show, isolate, view selected. Okay. So now we're looking at just the ball. Let's minimize this so we have a little more viewing space. So I want the squashing and stretching to happen from down here. Now this will probably change our animation a little bit, but it's okay. We don't have a lot of keyframes to edit, so we'll do that. So we're going to move the pivot of the ball from the middle to the bottom, so that when we scale it and squash and stretch it, it scales from the bottom out, and we don't have to do a whole bunch of realignment on our translates on every time we squash and stretch. So let's press the insert key on the keyboard to get this little manipulator. Drag it down. Press V to get the vertex snap, and just drag it right there to the bottom. Press insert to get out of it, and sure enough, we can scale from the bottom now. But I think this has probably made a slight error or adjustment. Nope, we still hit the bottom just fine. Okay, excellent. Excellent. Okay, so what's very important when you're doing squash and stretch is that you maintain the overall sense of volume. When we do squash and stretch, we can't just, for instance, we can't, let's see, there's my little animation. So we'll just go down to scale Y here on the ball, scale Y. Okay, so we'll start here, boom, at the peak, we're going to be, boom, So then we land here, we want it to squash. I can't just grab scale Y. Oh, darn it, I moved the pivot on the wrong piece of the ball. Alright, so let's backtrack just a little bit. Sorry about that, guys. I made a mistake. Hopefully you're doing what I did and watching the video first before you try it yourself. So let's press Control 1 to isolate select. Insert to get the pivot. V to get vertex snap. Insert. There we go. Alright. There we go. Okay, so if I just pull it down on Y, it's not compensating, right? The volume is disappearing, right? So this ball here is less volume than this ball. When I squash and stretch, I want the volume of this ball to remain the same. So when I pull this down, I got to recover the volume, right? So if I pull this down to 0.259, right, that means it's going to be what, like a volume loss of 75%. So I got to recover 75%. So I have to take 1 minus 2.59 and then divide that result by 2 and put that value in scale X and scale Z. So, you know, you're going to be stuck doing stuff like this. You know, get used to your calculator. So, 1. I'm sorry. Yeah, 1 minus 2. All right, sorry. Let's start over. 1 minus 0.259. Okay. What the hell was that? Okay, sorry. 1 minus 0.259. That gives us a total of, you know, 0.741. Almost 75% of the volume was lost. So we have to then divide that by 2, and we get 0.3705. So then we add that 0.3705 to each of these. Oops. 1.371. Okay. So now this ball is roughly, this isn't completely accurate, but it's good enough for visual accuracy. There were some things that weren't accounted for, but that's a simple way of doing it without getting into an expression. But we're going to get into an expression. We're going to do this with nodes because, frankly, if you had to go through and do this kind of thing, setting a keyframe for this kind of scale for every bounce and stretch, you know, because like that was just one direction. You have to do it again in another direction if you want to do scale, right? So if you're doing stretch, you then have to subtract instead of add in X and Y. So there's a lot of tedium there, and there's a lot of opportunity to make mistake. And what happens is you stop being creative when you have that much kind of tedious work in front of you. So we're going to use a little bit of math, not calculation. Okay, we're going to understand how squash and stretch works and make a rule for the computer to follow. So what we're going to do is the volume preservation equation is actually well understood. This was something that I learned in high school geometry. I'm sure you guys did too. Probably don't remember it, but you did. So x, right, x-axis scale x equals 1, right? 1 is our basis, right? 1 is while everything looks right, divided by the square root of y. It's really that simple. And z is the same thing. Z is 1 divided by the square root of y. Now, if that scares you, that's okay. Don't worry about it. The computer handles figuring all this out. We don't have to figure it out. All we have to do is tell the computer that, yes, x does equal 1 divided by the square root of y. Yes, z does equal 1 divided by the square root of y. It will figure out what those numbers actually turn out to be. So let's do that. On our ball transform squash and stretch node, let's go to the Windows, Node Editor. And wow, look at all that. It's got all sorts of stuff figured out there for us already. That's not cool. So let's go ahead and let's take out all these keyframes on rotate XYZ, scale XYZ. So what you're seeing here is like all these curves that you're seeing in here, they have a representation as a node. So Don't let that scare you. Oops, I deleted too much there. Boom, select this guy, graph everything out. Okay. There's scale X, scale Y. All right. If I drag a box around those guys and delete them, yes, it deleted them. All right. So hopefully, let's yeah, don't want to do the, so we want to make sure my translates are safe because we want to keep those guys. Select the ball again, and then select rotate XYZ and visibility, draw a box around them, and delete. Okay, cool. You know, there's all sorts of neat things you can do with these, but we're not going to worry about that just yet. You can drive anything with a curve in Maya, but that's a little bit more advanced. But you'll get into it if you want to make a career out of this stuff. All right, so there's what we want to work with. We want to work with a scale X, scale Y, and scale Z. So once again, this node editor is new to me since I use Maya, so I know what node I'm looking for. I just don't know where to find it in all the menus and everything. So we're going to go ahead and just search for it. What we're looking for is multiply divide. So press tab and type multiply divide. All right, click these guys, get all this input here. So input 1, input 2, and output. Just expose all that so we can look at all that right there. Okay, so if you remember, our equation is 1 divided by the square root of y. Before we can do the divide by 1, we have to first know what the square root of y is. And a multiply divide will do that for us. So if you double click on it, you'll get its attribute editor. So the operation by default is set to multiply. We want to set that to power. And since we're working with y, these right here, these input 1 and 2, each, like the first one is x, the second is y, the third is z. To keep it simple, I'm going to go ahead and just use the second one for y. So let's see if the power power of 1 is that, so you want to do 0.5. That's the square root using the power node. Now we'll take the scale y and put that into input 1. So we're taking the scale y and we're getting its square root. Now press tab again and type multiply again. Oops, helps if you actually spell it right. Multiply divide. And you want to turn its operation into divide, and input 1 is going to be 1. And we need to put the result, the y result of the first multiply divide, into input 2. Input 2y, not input 1. Make sure you get that right. All right, so if you get the divisions mixed up, you're going to have a bad time. You're not going to get what you're expecting. And then we take the output of this second multiply divide. So we'll call it, let's go ahead, we'll call this the SQRT of y for square root of y. And then we'll call this the divide SQRT for square root. Divide the square root. So we know what these guys do at a glance. So then we'll take the output of y and put it into scale x and put it into scale z. Now let's go look at what we got here. So far, nothing. So far, it's nothing. We got ones here. If we look over here in our channel box, we got ones everywhere, which is great because we want to be able to have this ball with no distortion or no squash and stretch. But as I pull down, as I pull down, there we go. Look at that. You see how it stretches out and squashes in, squashes out, boom, stretch. So now when we're going through and animating our squash and stretch, we just have to grab this Y handle. And if we ever want to get it back to normal, we just change the Y back to 1. Somebody's got a little distorted down here. It's this guy. Alright, maybe we should lock that. Let's see here, Windows, if I can remember how to do this. channel control, I believe. Yes, channel control right here. It's under general editors, channel control. And we'll take scale X, Y, and Z, and I'm on the ball. I am not on the squash and stretch. I am on the ball, and I will move them to non-keyable hidden. All right, so yeah, they disappeared. They can't get keyframe now. Can't make that mistake anymore. Boom. And there you go. You see we've got inputs. We've got divide the square root and the square root of y. And it tells you what kind of values we're getting. This is what we're getting for, this is what the square root of, oh, dang it, I shouldn't be able to change those. I don't know why it lets me do that. So be very careful. You can't select things in your viewport. If you select it in your viewport, you're going to get the ball. So make sure you're selecting in your outliner now. Yeah, so let's see here. There's the scale. Boom. So let's see here. What happens when we go to 1? Then divide square root. Look at that. Square root of 1 is 1. Divided by 1 is 1. That's why it works. And the square root, we're using the square root because we have to divide things out by axis, right? So here's the neat thing. Like if you, like it's always handy to think of square roots as basically like as a square, right? And we basically, you have these two vectors here. They make basically a square. I mean, this gets a little more advanced, but these little directions, a vector, a single vector can describe a whole area, which is, you know, that's pretty neat stuff, especially as you get more into 3D animation. You know, you can get the computer to do more of the tedious work for you. All right, so now we've got a squash and stretch control. Let's start animating it. So let's start out with, we'll select here and a scale Y, and we'll just do I'm selecting in the channel box the scale Y, and I'm selecting the key selected, right click, key selected, just that guy, all right, just to get some values down here. So now if I look in my channel box here, I see that there is a scale Y. There's a scale Z, but the scale Z's are, there's a pin underneath them that shows the squash and stretch and all that, or that's being driven by the scale Y here. All right, so with scale Y, we're going to advance forward, and I'm just going to go here to the first contact, and I'm going to push this down, like that. Boing. Okay, I mean that's not perfect, but you know, just like we're just going to go through here. Let's get our translate Y visible too. All right, so we want to get this right here. We want to actually move that back, because remember we're doing a hold pose. That there. Go forward one, get another. There's a little bit of straight ahead information for you. I mean, well, not really, but sort of. All right, so at the peak here, where the ball is peaking, at the top of its peak, I actually want it to have no squash or stretch. So it's basically perfectly round. So I went ahead and just entered the value of 1 when I got to the peak here. Highlight that, key selected. Boing. Once again, get to the peak. 1. In fact, I'm going to just go through to all peaks and key them to 1 right now. Save a little bit of time. Because I know that that's what it's going to be. It's another rule. It's probably a way to do that with a script if you really wanted to, but we're not going to do that. We're going to get the practice of making observations and setting keyframes based on that. All right, so now all of our peaks, we have a scale of 1, right? So there's no squash or stretch. So let's now go through the bottom here and let's play with it a little bit. Let's enjoy setting up the squash control. Go to the first hit there, pull it down, set the keyframe, advance 1 for the hold, set a keyframe. Same deal, pull it down. And remember to try and lessen the amount of squash and stretch dependent upon the force that the ball is hitting the ground with. So if the ball isn't traveling very far, maybe it shouldn't squash and stretch as much. Unless it's really made out of like maybe it's like a water balloon. Then it squashes and stretches really easy. But if it's like a rubber ball or if it's a bowling ball, you want almost no squash and stretch, right? You still want a little just because it adds a visual punch. But a bowling ball wouldn't squash and stretch as much as a water balloon would. And it's a little rubber ball, depending on how it's bouncing, you know. This is another one of those areas where you tell a lot about what your ball is. What's it made out of? And that's just a tiny bit there. That's not much at all. Okay, so you see something here, right? We went ahead and we went and put squash in. I don't even need to play blast this to see this problem. We're not even at the ground yet, and we're like, bam. That's just not right, you know. That's crazy. So while it's accelerating, right? We got to think about we want to start to stretch actually, right? Let's even do a stretch here, right? And as it starts to fall down, right? You think about how much force is being applied to this ball as it falls down. Let's stretch it out to match that force. Uh-oh, you see that? See that tangent there? Let's go ahead and correct that. That's actually, let's see here, let's back up here. Back up there. So what's happening is we're keying on our arcs here, and we don't want to do that. So with scale Y selected, key selected, can't just hit S. We don't want to mess with our arcs. Spend a lot of time setting those up, those bounce arcs. Let's not screw it up, being careless. Key selected. Selected is the Y. Okay, yeah, look at that. All right, well, we're going to go in and fix that with tangents. So what I'm looking at there is like okay, boom. It's going stretch, stretch, but it starts to squash. It's a little, that's not the right kind of anticipation we're looking for. So as it goes back up, stretch it out. And don't worry about getting these right. We'll go in and we'll look at the graph and we'll take an analytical eye to how these things should be coming together. Let's get a little closer to that squash point. Look at that. You see how that's changed the animation entirely? I haven't even play blasted it yet, and you see this like it's bouncing along. The hold is going to make a lot more sense since we have a. Remember how we hold the bottom here? It's going to be a lot more visually appealing since we've got squash and stretch. It won't look like it's just sitting there because we're going to let the squash and stretch calculate pass-through values on that. So it will be moving, but the movement it's making will be a squash and stretch. All right, let's just keep going through here. Remember, right-click, key selected. Don't just press S. Stretch it out. Stretch. Key selected. Let's advance some more. Boom. Up it goes. Key selected. Keep those nice bounce arcs clean. Stretch. Key selected. Oh yeah, we'll take a look at this analytically here in a sec. It's a bit of a mess, but even though it's a bit of a mess, since our arcs were so foundationally strong, you don't notice that mess as much. As it goes up, stretch past one. See how nice this is? Like, instead of having to key 3 channels, we key 1 channel and we get the other 2 calculated for free. Any changes that we make to that 1 channel get automatically updated in the other 2. Scale X and Scale Z update automatically for us. Thank you, computer. Math is fun, calculation isn't. Well, I don't think it's fun. There are people that enjoy calculation. I'm just not one of them. Really starting to back off on the amount of stretch I'm giving it here. And we'll do a play blast after this is done here. Alright. Lighting's starting to bug me. Seems a little too dark. Alright, let's go ahead and play blast. Alright, those hits are looking a little too strong. But it's looking better. I mean, the lack of rotation is pretty obvious now. Maybe we'll look at addressing that here pretty soon. But we got to work out the rest of the squash and stretch. But yeah, you see how much more lively that is? Oh, I've got an idea. Let's do some motion blur. So, motion blur is very cool. It actually kind of reinforces the anticipation. So let's go to renderer, viewport 2.0 options, and there's motion blur right there. Enable it and start dragging. So be aware that this may make your video card, depending on what you've got for a video card. I've got a 2080 Ti, so it smokes this kind of stuff no problem. But if you have an older video card, it may not look good. If it doesn't look good or it slows your scene down too much, turn it off. We can always render out the motion blur with Arnold. Let's do a play blast, see how that looks. Did it turn on? I don't think it did. It's enabled, okay. Oops. Alright, maybe you need a little bit more there, okay. Lots of samples. Yeah, it's doing a little bit of it. Turn that grid off too, that grid's getting annoying. There we go. Don't like looking at that thing. There it is, yep. Motion blur helps it. Gosh, what is that artifacting? Oh, I think I know what it is. Not enough divisions. Or something, maybe, I don't know. Alright. Okay, well, next chapter we're going to go in here and we're going to clean up the squash and stretch a bit.